Hey, Bio students, let's see if we can finish up notes today. Um, we've been talking about chemical reactions and how our whole body is pretty much run by chemical reactions. Life doesn't exist if we don't have chemical reactions occurring, by the thousands all the time. So the key to it is, and I showed you some videos yesterday of reactions which explode and send off fireballs and stuff like that. But we don't want that happening in our body. So how do we control those chemical reactions so they don't get out of control and they don't explode and we can have normal operations so we feel good and we do our thing. Enzymes is the big key. Okay, so enzymes, as you see on our screen here, they speed up chemical reactions. Temperature, pH, regulatory, they all can affect the activity of organisms and enzymes. And that's basically why our body temperature is at a certain point, because that's where enzymes work the most efficiently and chemical reactions work the most efficiently. So I want to go through enzymes a little bit today. And they get kind of complex. We'll try to break it down and simplify it as much as we can. So some chemical reactions just occur way too slow. They have activation. We talked about activation energy yesterday. The activation energy is just too high for practical use, so we have to have enzymes in there to speed things up. And here's where it gets a little sketchy. So chemical reactions are made possible by catalysts. Catalyst is a substance that speeds up the rate of a chemical reaction. Okay, here's the saying I'm going to say, and it's going to be kind of confusing. I'll explain it a little bit as we go. All catalysts are enzymes, but not all enzymes are catalysts. Okay, so I know that sounds a little weird, but catalysts work by speeding up the rate of a chemical reaction by lowering the activation energy. So it doesn't take as much activation energy to get a reaction started. So by dropping it down, we can start that chemical reaction at a lot faster pace. I will show you an example of that here in just a second. Okay. And enzymes are proteins that act as biological catalysts. So that's what speeds them up. They're just proteins we've been talking about. That's one of the macromolecules, a protein. Okay. And they lower that activation energy, and it can be quite dramatic. Look at this little graph down here at the bottom. Okay. So if you look at the blue line, you can see how it basically, without an enzyme, it's going to take a huge amount of energy to get it going. It takes a long time, and you can see how that works. By putting a catalyst in here, we speed that up a lot faster. Okay, and that's all we're doing. Don't make this complicated. Enzymes are just proteins that catalysts that they just speed things up and make things work more efficiently in our body. And that's basically what we want to talk about today. So let me give you a pretty dramatic example of this. So we just got like 3 more slides, okay? So let's take carbon dioxide. Carbon dioxide combines with water to produce carbonic acid. And carbon dioxide builds up in our body faster than our bloodstream can get rid of it. So we gotta get rid of it. If we don't get rid of CO2, we don't live. Okay, we die. So CO2 and water produces this H2CO3, which is carbonic acid. Okay, and then we can get rid of it, and we breathe it out every single day. Okay, your bloodstream contains an enzyme called carbonic anhydrase. You think enzyme is an enzyme. Okay. And that speeds up the reaction. Check that out. Look at the number down at the bottom of the screen. By a factor of 10 million. Let me say that again. By a factor of 10 million. So that reaction takes place like that. In normal speed, without the enzyme, if we don't have carbonic anhydrase, then that would go so slow that we would die from CO2 buildup in the blood. So that's what we're talking about. I know that's a dramatic example there, and I'll put these notes on online today, and you play this video. It's really good to watch, and I'm going to do it right now. But it's crazy how fast that